Hi guys, today we're going to learn about the root test. So, what are the conditions of the root test? We say that a series from n equals 1 to infinity, a sub n, converges if the limit when n approaches to infinity, what you're going to do is you are going to apply the nth root of the absolute value of the a sub n, meaning we're going to take the a sub n, the nth term, okay, and then you're going to take the absolute value and take the nth root, okay, and that needs to be less than 1. If that limit gives you a value that it's less than 1, it's going to converge. Now, the series, okay, from n equals 1 to infinity of a sub n will diverge if the limit when n approaches to infinity of the nth root of the absolute value of a sub n is greater than 1. Now, pretty similar to the ratio test, if the limit when n approaches to infinity of the nth root of the absolute value of n gives you that it's 1, the root test is going to be inconclusive, so another test would need to be used instead, okay? So, what are we going to do here? You are going to tell me, when are we going to use the root test? The root test is going to be pretty much when you are having, okay, terms of the series raised to an nth power. So, for example, what do you have here? You have the summation from n equals 1 to infinity of e, and the power is 2n divided by n to the power of n. The power being n in both situations, that's giving you the hint of using the root test. Okay, so what do you have here? We have that you are going to have the limit when n approaches to infinity, okay? And then what we're going to have here is e to the power of 2n divided by n to the power of n. Apply the absolute value. What we know is that the nth root, okay, you know that this is equal to a sub n to the power of 1/2, so I'm going to put the 1/2 here, okay, not 1/2, 1 over n there, okay. So what happens here? Since you have the absolute value using the properties of exponents, technically speaking, what you are going to have here is that this 1 over n multiplies the 2n, okay, so you would have e to the 2n divided by n, so you would have that it's going to be e squared, which you know that it's positive. We can keep the absolute value in case that you want to be safe, but you know that that's positive. And then you apply this one using properties of exponents, 1 over n times this n, so you know that you're going to have your plane n. So what happens here, you know that this is a constant, e to the power of 2 is a constant, divided by, technically speaking, infinity. So you do know that this is going to be 0, which is less than 1. So what do you have here? Thus, you have that your original series, n equals 1 to infinity, e to the 2n divided by n to the power of n. What's the business here? Okay, it converges, okay, by root test, okay. And let me tell you something very important about this test. Since you apply the absolute value here, guess what? This is also absolutely convergent, convergent, okay. So this is telling you that it's convergent very powerfully, okay. So this is an FYI. If you apply either the root test or the ratio test, since you are applying the absolute value, you also know that the series, your original series, is going to be absolutely convergent. Isn't that nice? So let's see the next example that we have over here. So you have the summation from n equals 1 to infinity, and you have 3n plus 4 divided by 2n, and all of this is to the power of n. This power of n is the one that I was telling you, that if you have something to the raise of the nth power, like this one, you're going to use the root test, okay? You can see that you cannot apply the nth term test for divergence, the geometric series test doesn't work, the p-series test doesn't work, you don't even want to integrate that because it's a monstrosity, okay? So that's why, okay? So in case that you're wondering why. So we apply this beautiful test. So you have the limit when n approaches to infinity, and then you have that it's going to be what? 3n plus 4 divided by 2n. Okay, you raise this to the power of n, then you apply the absolute value, and then you have the 1 over n, which you know that it's the same as the nth root. Okay? Similarly to the previous example, you know your properties of exponents very well. So what are you going to do? 1 over n to the power times n is going to be the power of 1. So what do you have here? Okay, so you're going to have that it's 3n plus 4 divided by 2n, because these two, you have n over n, that's going to be 1. Okay, so put the absolute value there. Okay, so what's the business on this one? You have that exponents are the same. You have a polynomial degree 1 here, a polynomial degree 1 here. So it's going to be what? 3 over 2. Exponents are the same. Divide coefficients. My coefficient of the numerator is 3. My highest coefficient of the denominator is 2. So you have that beautiful number, which is greater than 1. And guess what? Thus, since it's greater than 1, what can we conclude? My original series from n equals 1 to infinity, 3n plus 4 divided by 2n, all of it to the power of n, diverges, okay, by root test, okay? And that's pretty much for the root test. Wasn't that simple? I hope that you find this video helpful. Bye.